Let's try some more examples of expanding. And remember, expanding is we go from one log to multiple logs. All right, we have log base 6 of 36 times x plus 2 to the third. Because it's multiplication, which makes us bigger, we are going to use addition because addition also makes us bigger. So log base 6 of 36 plus log base 6 of x plus 2 to the third. We can't break up the x plus 2 because it's addition. It's not multiplication or division or an exponent. But it does have an exponent, so let's take care of it. Now 3's got to come down. In doing that, we have log base 6 of 36 plus 3 log base 6 of x plus 2. We do not have any more multiplication in our arguments. We don't have any division. We don't have any exponents. So our last thing is to make sure that our base and our arguments have nothing in common. And if you look at our first one, we have log base 6 of 36. Log base 6 and then that 36 have something in common. We can rewrite 36 as 6 squared. And then carry along our 3 log base 6 of x plus 2. Because we rewrote the 36 as 6 to a power, we now need to bring that exponent down. We don't like exponents in our logs. So that becomes 2 log base 6 of 6 plus 3 log base 6 of x plus 2. Okay. No more exponents, no multiplication, no division. We go back through, we do one last double check, make sure that our base and our argument have nothing in common, but we still have log base 6 of 6. Remember, when your base and your argument are the same, it's going to equal 1. So now we have 2 times 1 plus 3 log base 6 of x plus 2. And simplify it because we know 2 times 1 is 2. And then plus 3 log base 6 of x plus 2. We cannot combine the 2 and the 3 because of the 3 being attached to log base 6 of x plus 2. Let's try our next one. I know it looks icky. We'll be fine. Remember, if it's in the numerator, it's positive. If it's in the denominator, it's negative, because division makes us smaller. So anything we're dividing by needs to be subtracted, which also makes us smaller. Breaking it up, we're going to have log base 5 of the square root of x minus log base 5 of 25 minus log base 5 of y cubed. Notice that both the 25 and the y cubed are negative because they came from the numerator. The log base 5 of the square root of x is positive because it came from the numerator. All right. If you're looking at that square root of x saying that, this is just not okay, you're right. We need to rewrite him as an exponent. Remember, if you don't see the index, it is a 2, which means that we can rewrite our square root of x as x to the 1/2 because it was x to the first under the radical. Whatever your index is becomes the denominator of your exponent. Minus log base 5 I'm gonna save us a couple of steps, which I probably should have done in the last one, but here we go. 5 and 25 have something in common. 25 can be rewritten as 5 squared. Then we have minus the log base 5 of y cubed. That 3 needs to come down because we just don't like exponents in our logs. So 3 log base 5 of y. Back to the front. That 1/2 needs to come down because he is an exponent. It's going to become 1/2 log base 5 of x minus 2, bringing that down, log base 5 of 5. But remember that log base 5 of 5 is 1 because the base and the log are the same. Or sorry, base and the argument are the same. Which means when we simplify for our answer, the 1/2 log base 5 of x stays the same. But instead of 2 log base 5 of 5, we have 2 times 1, which is 2. So minus 2 minus 3 log base 5 of y. So yes, you can start to skip a couple of steps. Don't skip so many that you can't show that you're doing your own work. One more like this. This time the radical is over the entire argument, not just a little piece of it. So I'm going to start by rewriting that radical first. I'm going to have log base 2, and I'm going to put in some parentheses. 8z squared all over y cubed. And this time when we have the 4th root, it's going to be to the 1/4. And since it's an exponent for everybody, it comes out front for everybody. So I'm going to put in a bracket. We have 1/4 log base 2 of our fraction. Okay. I'm going to continue with that 1/4 and bracket, and let's break down the log. Remember, if it's in the numerator, it's positive. If it's in the denominator, it's negative. And that's because numerator positive multiplication, which makes us bigger, addition makes us bigger. And when we divide, we get smaller, which is the same thing that happens with subtraction. So we're going to have log base 2 of 8, since it's in the numerator, it's positive, plus log base 2 of z squared, again positive because it's in the numerator, minus log base 2 of y cubed. Let's go back through and look at each of our logs. Log base 2 of 8, we can rewrite as log base 2 of 2 to the 3rd, because 8 is 2 cubed. Then we're going to have plus 2 log base 2 of z, bringing down the exponent, minus 3 log base 2 of y. Almost done. We know that 3 needs to come out front. So we're going to have 1/4 times 3 log base 2 of 2. But we know log base 2 of 2 is 1. Plus 2 log base 2 of z minus 3 log base 2 of y. And now our arguments have nothing in common with our bases because 2 and z are different as are 2 and y. No more multiplication, no more division. In our logs, the one last thing we have to do, here I'll write this so it's not so ugly yet. We would have 1/4. 3 times 1 is 3 plus 2 log base 2 of z minus 3 log base 2 of y. Last step, we need to distribute that 1/4 all the way through. When we distribute and you get fractions, or sorry, you get decimals converted back to a fraction. So 1/4 times 3 gets us 3/4 plus 1/4 times 2, 2/4 gets us 1/2 log base 2 of z. Notice that it is not going inside the argument, it's just on the outside. And then negative 3 times 1/4 is negative 3/4 log base 2 of y. And yes, you have to have the base 2, otherwise your answer gets marked as incorrect because you do not have the correct base.